welcome to the session. So in this particular video, we will talk about in complete depth about the tree traversal algorithms. So far I am assuming that you are completely aware about what is the basic idea and intuition behind a tree data structure, right? Now, how many ways are possibly there to traverse all the nodes in the given tree? For example, here I will create one tree for you all. For example, this is the tree which is given to us. So here I am talking about the binary tree only. Okay. So for example, this is a kind of a tree that I have. Right? Now, in this particular binary tree, how many ways are there with the help of which I will be able to reach to each and every node inside the given tree? So that is something which we are saying as tree traversal algorithms. That is something which we can say as tree traversal algorithms. Now, in today's class or the session, we'll try to understand that how many different kinds of algorithms are there to traverse each and every node inside the tree. So mainly if I will talk about tree traversal algorithms, we have three broader category, I would say. One is called as Inorder traversal, the very first which we will study in our class. After that, we will talk about something called as Preorder traversal. Fine. And the last but not the least is the Postorder traversal. These are the three, I would say, standard or the major categories to traverse each and every node inside the tree. Later part of our tree data structure, we will also talk about one more traversal called as level order traversal. But as of now, let's talk about these three standard traversal algorithms, which are Inorder, Preorder and Postorder, to traverse or to reach to each and every node inside the given tree. So let's get started with the very first traversal algorithm, which we are saying as the Inorder traversal algorithm, right? So what will usually happen in Inorder? For example, a tree is given to you like this: 1, 2, 3, 4, 5, 6 and 7. So this is a kind of a data that you have inside the tree. Now what this Inorder traversal will do? In order to understand first of all these traversal algorithms, you should have a good understanding about the recursion concept again, which we already studied in our previous modules of our batch or of our module, right? We already have a great discussion about the recursion concepts. The traversal algorithms we can do with the recursion. It will be very much easy for us to understand in that sense. But by saying that, I hope everyone knows that for every recursive code, we have a iterative solution as well. So what we will do here is that in my course, I will cover up the recursive approach. But what's your assignment problem is that given those recursive approach, once if you will be able to understand the concepts of how basically traversal will happen in case of Inorder, Preorder or the Postorder, your work is to do the same thing without using any recursion. That is the assignment problem, or you can say the practice set problem for yourself. So let's get started. Whenever we are talking about a Inorder traversal, it says that what I will do here is that inside the tree, I will first of all traverse the left side of the tree. I will first of all traverse the left side of the tree. Fine. After that, I will print the root node. After that, I will print the root node, right? And at the later part of the traversal, I will go towards the right side of the tree. And this way, I will continue the task of traversing to each and every node inside the given tree. So basically what will happen, let me try to create the tree again here. For example, this is a kind of a tree that we have, right? Here, this is the data that is given to me: 1, 2, 3, 4 and 5. Now what I am saying here is that I am saying one simple thing. What it will do is that it will just, we will call the function Inorder by passing the root node, right? until the root value is none. If the root value is not none, what it will do is that it will try to go inside the function and first of all call the same function again, but by traversing the left side first. So it will pass root.left. That is what I want to convey here by mentioning the first line. Then what it will do is that it will try to print the data of the root, whichsoever data is there. And after that, it will try to traverse towards the right side of the root. That is the way of traversal in case of in-order traversal. So if whenever you are seeing the word in-order traversal, this is the by default approach which it will use to traverse towards the every node inside the given tree. So for example, if you'll see this example, and if I'll talk about that, what is the output your code will give you if this is the tree that you are having. So what you will say to me that first of all, we all know that this is something which we called as a, I would say, root node. This is something which we called as the root node. And the node which is not having any child is something which we simply called as a leaf node. Can I say? Is something which we called as a leaf node. This is a root node and this is a leaf node that we have. Now what we will try to do here is that we will try to simply start with the root node. So the data will pass as in order of root, which is equals to 1. Simple. Now once it will go to 1, now if 1, so 1 is not null, right? So it will go towards the 3 statements and will try to basically, I would say, traverse each and every statement. So first of all, if you will observe here, this is the method name and this is the thing that we are calling it again. And this is something which we called in simple terms as the concept of recursion. This is something which we called as the concept of recursion. So what we will try to do here is that we will call the root left. So what is the value present at the left side of the root? It is something, can I say, as in order of 2. Can I say? In order of 2, right? Again, if you will see, this function will be called. After that, the second statement is saying print the data. So print the data of the root. So here I am printing the value 1. And the last thing it is saying as traverse again the function with the right side data present, which is 3. So here if you will see, third statement is if third statement will be executing, it will pass in order of 3. Now according to the function calls, this in order of 2 will run first. Again, what is recursion? At the parameter 2, it will do the same task again. So it will again check if the root is none or not. If you will observe here, again the root is not none. The value of the root is 2 here. So again it will try to do the 3 things. First thing, it will go and check the left side of 2. Here if you will see, left side of 2 is nothing but is equals to 4. So what will happen? Again 3 statements will get executed. It will call in order of 4, right? After that, second statement will say print the value of 2. Third statement will say call the same method again with the value present at the right, which is 5. So what will happen is that it will call in order of 5. It will call in order of 5. Can I say? So again, what will happen? The very first function call will be executed. Again, the 3 statements will be called because the value of the root which now will pass is 4. That is the simple meaning of recursion, right? So now again, the 3 statements will get executed. Now, what is the value present at the left of the 4? Because there is no value, can I say that it will be nothing but is equals to null only, right? Similarly, if you will see on the right side also, none only. On the right side also, there is none, right? As there is no left, no right, it's a leaf node. So can I say that the value at the left part of the node is something which is nothing but is equals to none? On the right, on the middle part, I will print the value of 4. And on the right part, I will again call the function in order, but now with the value of none. Can I say? And once it is none, it will not go inside the if condition and it will not do anything. So simply this will be returned, right? This will be returned. After that, 4 will be printed as the very first output. So this will be done. After that, this will be returned. After that, this is completely done, right? After that, what will happen is that 2 will be printed. After that, again, in order of 5 will be called. So how basically recursion is happening? We are calling first of all in order of 1. So the function call will be something like this. So we are calling, so if I will say this is C1, C2, C3, C4, can I say? After that this is C5. So C1 will be called, followed by C2 will be called, followed by C3 will be called, followed by C4 will be called. And once it is done, again the value of C5 will be called. Once it is done, then completely C3 will be done, right? Once C3 will be done, what will happen? The function call will go back to C2. I hope everyone knows now how recursion will work. The same thing which I am doing here. Now the middle portion will get printed, the value of 2. Now again what will happen? C6 will be called. C6 will be called. Now at C6 again, if you will observe, the root is not equals to none. So again the 3 statements will get executed. On the left I have none. On the middle I will print the value of 5. On the right I have again none. So what will happen is that I will again go towards left side. It will print the value as in order of none. Then I will print the value of 5 in the second statement. And after that I will say in order of none again. So what I can say is that C6 will call C7. C7 will get directly returned, right? C6 will call C7. C7 will directly return. After that, it will simply execute the print statement. 5 will get printed. After that, what will happen? C8 will be called, right? C8 will be called. Again, C8 will also return because the value of the root is equals to none. Once this will be done, C6 will be called. It is also done, right? C6 will be done. After that, the function call will go back to C2. Now, at C2, what will happen? I think this is completely done because C3 and C6 is completed. After that, the second statement was 1, which will be executed now, right? After that, what will happen? C9 will get executed, which is in order of 3. So now the next important part of the thing is right side, which is C9. Now here if you will observe, at C9 again it is not equals to none. So 3 statements will be executed. One is at the left side of 3, one is the printing of 3, one is the right side of the 3. So here again if you will observe, it will call in order of none at the left side of the 3. Then it will simply try to print the value as 3, and again at the right side it will simply print the value of in order as none. So what will happen? C9 will simply call the value of C10 and C10 will get executed and will return the statement. So C9 will call C10, it will simply return that, right? After that it will call C11 after printing the value of the 3. So 3 will get printed and after that C11 will also get returned. Once the value of C11 will also get returned, the function call will go back to C9, it will got returned, right? And after that finally the value of C1 will also get completed. So C9 is completed, C1 is completed. So at the end of the stack, I would say you will observe that your data structure is empty only. Stack is empty only. But what kind of output you will be able to get? You will get 4, 2, 5, 1 and 3. So if you will observe also, if you will not create this kind of a recursive tree, which I usually create whenever there is a recursion, just to show you internally in depth how things are happening here, right? So here if you will observe what is happening, the function call will go back to left until we go to the none, until the value of the node will reach to none. So it will go and it will say 4. After that, it will say the value as 2, the parent node, then 5, then 1, then 3. This is what is happening in case of a in order by seeing the 3 statements that we have. And this will keep on happening until the value of the root is not equals to none, right? I hope that this part or the intuition behind the in-order traversal is pretty much clear to everyone, right? Now what we will try to do is that we will try to see the implementation of same, and by taking the same tree, we can take the same tree 1, 2, 3, 4 and 5, and we'll discuss about how basically we can print the output, how basically we can do the implementation of this in-order tree traversal. And finally, after that, we will try to discuss the recursive or I can say recurrence relation to find out the overall time complexity for this, I would say, traversal part. So now let's get started with the implementation of the same, right? So what I will do is that I'll use the Jupyter Notebook environment. Let me delete the cells first, whatsoever cells are there. Yep. After that, now let's get started with the implementation part. What I can do is that just like the previous ways I used to do, let me write the driver code first. Inside that, obviously what I will do, I will first of all try to create the root node. So here, if you will see, the node 1 is there. After that, at root.left, I will be having the data 2. Afterwards, at root.right, I will be having the data 3. Afterwards, at root.left, I will be having the data 4. And after that, at root.left, the data is something which is equals to 5. So this is the tree which I have created, which will be similar to the tree that we have discussed just now in our class, right? So here, 1 is there, is the root node. At the left side of the root node, I have 2. At the right side of the root node, I have 3. At the left side of 2 is 4, and at the right side of 2 is 5. So this is root.left and root.left.right. So according to the above tree, our result should be 4, 2, 5, 1 and 3. This also we already know, right? So let's get started. Now this is the same tree which we are using here. Obviously this node is a class which I will define just now. Give me a second. Now what basically we can do is that we can simply print that as in-order traversal, right? And inside that, what I can do here is I will start basically calling the function in-order traversal, where I will just pass the root node. So this is something where I am doing the function calling, I would say. Now what I will do here is that I will do the function definition here, right? Here, if you will observe, I have def in order. Inside that, I will be having the root node, right? Now what I will do is that I will say that until or unless the root node value will become null, do 3 things for me. First of all, go and traverse towards the left side of the root node, which is root.left, right? After that, print the data, which is root.data. After that, call the same function again and print the right side of the root node, right? What I can do here is that I can do one more thing. For printing purpose, I can say print root.data, and here I can just convert this into a string str. I will do this typecasting just for the sake of presentation purpose. I'm doing this. After that, what I can do here is that I can just add this kind of a symbol, and after that I can say and is equals to, so there will be a space. Perfect. I think this is fine. Let's see if we got some error. So here, if you will see, we are somehow getting a perfect kind of output, right? Where we will be having, if you will see, 4, 2, 5, 1 and 3. So let me just go back to the documentation which we are using for the understanding purpose. So this is the expected output, can I say? 4, 2, 5, 1 and 3. And that is what, if you will observe, we are getting here. 4, 2, 5, 1 and 3. This seems bit odd to me. If I will just, this is better. So here, what we are doing, we are just traversing it by calling a recursive call. So here the recursive call is happening for the left subtree, I can say, and in this part the recursive call is happening for the right subtree, correct? So this is the kind of approach that we are doing here. So this is all about the in-order traversal. But suppose here I didn't created one thing, that is the class. Let me create the class node. I didn't created that, but still we got the output. So here if you will see, we will be having a init method where I will do the initialization and I'll say self followed by the data, right? Here I will define the node as self.left, which will create the value as none, self.right. So self is an instance of the current class that we are using, right? So here if you will see, self.data is something which we are passing as the data here. Now it makes much better sense. It's important to define the class which we are calling here, correct? Now this seems to be fine. Now what we try to do is that we will try to see the other different kind of ways to do the traversal. So until so far we have seen what is in-order traversal, right? Here if I will talk about the recurrence relation of the same, if you will see here, half of the elements are towards the left side, if you will assume in the best case scenario, and half of the elements will be towards the right side in the best case scenario, right? And what I will say here is that this printing will obviously take a constant time only if we are talking about a recurrence relation T of n here, correct? So here what I am saying is that whenever we are talking about a recurrence relation, specifically, so it would be something which I can say is equals to, in the best or the average case scenario, will be something which is equals to T of n, right, which is equals to 2tn by 2 plus the value of c. Now if you will try to solve this, maybe using a master's theorem or by applying a substitution method, right, we can solve it with the help of any of the approaches. So suppose I'll try to solve it by using master's theorem. Perfect. By using master's theorem. So if you don't know about that, go to the very first module of analysis. You will find a separate module called solving recurrence relations. There I have a separate video of how we can solve any recurrence relation using a master's theorem that you can use for your reference. Here if you will see, A is something 2, B is something 2, K is something which is equals to 0, and P is also equals to 0. So what is the value of log of A base B? It is something which is equals to 1. Can I say? So here if you will observe, the value of log of A base B is somehow greater than the value of K. And that's the reason we will be able to get the time complexity as big O of n to the power log of A base B. So it is something big O of n. So this is the overall time complexity that you are getting in the best or the average case scenario. Now, let's talk about the scenario which is something we can say is a worst case scenario. So what will happen in case of a worst case scenario? What will be the time complexity requirement in case of a worst case scenario? So in case of a worst case scenario, the overall time complexity will be something which is equals to T of n, that is equals to T of n minus 1 plus the constant. So here if you will observe, when the worst case scenario will happen, when you will be having something I would say called as unbalanced tree, right? Unbalanced tree, or I would say a skewed tree. That might be left skewed or right skewed, doesn't matter much. But the overall thing to understand here is that whenever we're talking about a worst case scenario inside a tree-based data structure, it means that either all the nodes or the maximum number of nodes are at the left side of the tree or at the right side of the tree. Similarly, when I am talking about a best or the average case scenario, by saying that, I am saying that we are here somehow talking about a balanced tree here, right? Balanced tree here. Perfect. But here we are talking about somewhere called as unbalanced tree or something which we call as a skewed tree. So here if you will see, the overall time complexity, if you will try to solve this again, will be something equals to big O of n. So in a nutshell, there might be a recurrence relation difference which you can observe whenever we are talking about a best case and the worst case time complexity in case of a in-order traversal algorithm. Even it's not the explanation for in-order traversal. You will see that for any traversal algorithm, this is the same recurrence relation which you will get, because somehow you will observe that same thing we are doing, we are traversing towards the left or right or printing the data. Now in what order we are doing that, according to that the naming will be different. For example, in order I am saying that firstly we are going towards left, then we are printing, and then we are going towards right. When I will talk about pre-order, I will say that first of all we will print the data, then we will go towards the left, and then we will go towards the right. In the post order we are saying that first of all go towards the left, then right, and then print the data. So anyhow, those three things we are doing in every traversal algorithm. So what I am saying is that this recurrence relation will be valid for every, I would say, traversal algorithm. So this will be valid for every kind of a traversal algorithm for sure, right? This is again a pretty much important thing to understand. For every traversal algorithm, this particular recurrence relation which we are talking about is equally valid. So here if you will observe, we have observed one thing. What is the important point to note here is that doesn't matter whatever be the scenario it is. For all the scenarios, means for every case, I would say, for every case, right, the overall time complexity is something which is equals to big O of n. The overall time complexity will be something which is equals to big O of n. That is the very important point here to understand, right? So I think this part is pretty much clear to everyone. Now let's talk about, as I have told you, something called as pre-order traversal. Pre-order traversal. So whenever we are talking about pre-order traversal, now it won't take much time for you to understand. Things will remain same. Again, recursion plays a very important role. The pattern of those three lines will get changed. So what will happen here is that we will say that if the value of the root is not none, do one thing for us. First of all, do print the data. So whatsoever be the root data that you are getting, print that first. After that, call the pre-order traversal on the left side of the root node, followed by call the pre-order traversal on the right side of the root node. Can I say? On the right side of the root node. So this is the overall structure for a pre-order traversal, I would say, where if you will see these three statements, statement number 1, statement number 2, statement number 3, these three statements are exactly the same that we already have discussed in our in-order traversal. The only thing which differs here is the pattern, the way we are traversing each and every node. So what will happen if I will take the same example and if I will try to demonstrate you that what is the output that we will be able to get to follow this kind of a pattern. What thing you can do here is that you can pause the video and try to do it on your own, and then unpause the video and try to check with that whether your answer will be correct or not. This will anyhow help you to build a good concept of recursion as well, again which plays a very important role. So here again if you will observe the function name, I can call it as preorder, and I am passing the root node inside this particular function name. If you will observe here, this is the same function which I am calling again. So here again I am using the recursion, right? Can I say? Here again I am using the recursion. Now let's get started with the same tree that we have. So here suppose I am having 1, then we will be having 2, then we will be having 3, then we will be having 4, followed by the value as 5. Now here if you will observe, again I would say root node data is 1. Can I say? So what I will do is that, let me try to create a recursive tree below. So again the pre-order of 1 will be called as a very first instance. Then once this function will be called, 3 statements will get executed. First of all, printing of 1 will happen. Secondly, the left side traversal will happen. So it will call pre-order of what is the value present at left side of 1, which is 2. And after that, what is the value present at right side of 1, which is equals to 3. So here if you will observe, 2 is present at the left side of 1, 3 is present at the right side of 1. After that, again, when we will go towards, so 1 will be printed. So finally, again, what will happen is that this is if suppose this is a function called C1, this is the printing, so 1 will print. After that, C2 will be called, right? So if I will try to create a stack-based data structure here itself, so what will happen? C1 will be called, C1 will call C2. Now again, what will happen? Again, the same statement will be running, 2 will get printed. After that, what is the value present at left side of 2? That will be called, so it will be pre-order of 4, which will be called here, and followed by pre-order of what is the value present at the right side of 2, which is equals to 5 will be called. So now if you will observe here, 2 will be called here. After that, this C3 function call will happen. So this will call function C3. Now at C3, what will happen? Again, those 3 statements you need to remember. 4 will be printed. After that, what is the value present at the left side of 4? If you will observe, there is nothing which is present as such. So it will simply say pre-order of none here, and at the right side also it is simply say pre-order of none here. So basically if you will observe, here the value simply will get returned because it will not go inside that if condition, and anyhow 4 will get returned. So basically C3 will be called, C3 will call C4 followed by C5. So C3 will simply call, I would say C4, and C4 will be returned. Then C5 will be called, C5 will be returned. After that, function call will go back to C3, and I would say C3 will also get returned now, right? After that, again function call will go back to C2. Now C2 will again call the next function, which is something which I have as C6. So C6 will be called. Now C6 will be pre-order of 5. Now again if you will observe, again 3 statements, 5 will be printed. What is the value present at the left side of 5? It will be pre-order of none. What is the value present at the right side of 5? Which is pre-order of, again, none. Can I say? So here if you will observe, C6 will call something that we can say as C7 and then C8. So here 5 will be anyhow printed. Then C7 will be called, C7 will be returned, C8 will be called, C8 will be returned because the value is none only, right? So these 2 things automatically will get returned. After that, C6 will be called, C6 will be completely executed. After that, what will happen? C2 will be called, C2 is also finished now. After that, now the final thing is C3, which will be called here. At C3, again, if you will observe, what is there? Pre-order of 3. So again, it is not none. So 3 statements will get executed. 3 will be printed. Then on the left side, we will be having pre-order of none. And on the right side, we will be having pre-order of none again. So here, if you will observe, what will happen? Anyhow, 3 will be printed. After that, C3 will call something called as, I would say, C9, right? And C9 will be returned, C10 will be called, C10 will be returned. So C9 will be returned, C10 will be returned, C3 will be returned, and finally C1 will be returned. So again, at the very end of the stack, you will get an empty stack only. Means all the function calls are executed now. So this is the output that you will be able to get now, which is 1 followed by 2 followed by 4 followed by 5 followed by 3. So if you will observe here again, you can also solve with this question without using any recursive tree. But because for the very first time I am telling you this thing, so as a beginner, I would say it's important to understand that how basically recursion works, how basically the recursive tree will be created. So here if you will observe, just simple thing that you need to do, print the root node, go towards left, again print the root node, go towards left, again print the root node, go towards left. None is there, nothing will happen, right? None is there, nothing will happen. Again go back and now print the value as 5. Again go back and now you can print the value at the right side. So you will again get the same kind of result only, but this is the result that we got with the proper logical understanding how recursive tree has created. And this is the result once you will be having a good practice. You don't need to create the recursive tree. You can do it on your own just by seeing how basically the code will work. Now, here if you will observe in the entire session of the traversal algorithm, I am again saying that I am using the concept of recursion. What you supposed to do after this session, after listening the complete entire session very much carefully, that you need to implement the same thing without using recursion, because this can be asked from you in an interview that, okay, first of all, they will ask you that, they will basically give you some tree and they will ask you that, can you tell me what is the in-order traversal of the same, or can you tell me what is the pre-order traversal of the same? Then for example, you will be able to answer them. Then he can ask from you, or he or she can ask from you that, okay, can you write the code for the same? Maximum number of time people write the recursive code because it consists of very small lines of code and it will be very easy to understand. Then obviously they will ask the explanation for the same. Then it would be good that if you will properly create the recursive tree that the way I used to create that, and then you can explain to the interviewer that how basically you will be able to get the output. After that, they will definitely ask you that, okay, I will get your point that how basically you are doing the thing with the help of a recursion. But can you implement the same thing without using recursion? So this is the question asked in Qualcomm very recently. So that's why I'm saying that this is your practice problem. So if I will do everything, then what is your research work? That is your research work. So please do it on your own, right? So with this, what we can do now, we can again start doing the implementation of the same of whatsoever we have discussed so far, so that both of the aspects we will get the clarity. So what we can do is that we can take the same code, and what I will try to do here is that I will try to simply do one thing here. I can again, so this is the function definition of, I would say, in-order traversal. In-order traversal. Now what I can do is that I can say that now I will try to do the function definition of, I would say, pre-order traversal. Pre-order traversal. So here what we will try to do, we can say def, and here we can pass pre-order. Inside that again there is a root node, and we can simply say if the root is not equals to none, do one thing for us. First of all, print the data. So here if you will observe, I am just doing the same task, the above task only, but the way to approach that problem, the way to approach any node is little bit different here. So here if you will see, what I will do is that I will try to print the data. I will first of all typecast it, and after that maybe I'll give a little bit of space just for the presentation purpose, right? After that, what I can do here is that I can do the recursive call. I can do the recursive call for the left subtree, and here I can say pre-order for the root dot left, and afterwards we can say pre-order for the root dot right, and in this way we are done with the task. Let me try to, okay, we didn't call this, so what we can do here is that now we can give little bit space here, and after that I can say print maybe the pre-order traversal, and here what we can do here is that we can say preorder and we can pass the root node again. So let's try to see. So 1, 2, 4, 5, 3. Are we getting the same output in our PDF as well? If you will observe, yes, 1, 2, 4, 5, 3 is something that we are getting in our PDF as well. So this is the simple coding implementation of the preorder traversal, right? So again here if you will see, there is a recursive call, and then further again there is a recursive call for the right subtree. Right? So here if you will observe again, in the best case scenario for a balanced tree, what will happen? Half of the data is on the left subtree, half of the data will be on the right subtree. So again the value of t of n is something which is equals to 2tn by 2 plus c. So the overall time complexity will be something which is equals to big O of n. In the worst case scenario, it will be something which is equals to t of n equals to t of n minus 1 plus c. The same thing that we have already covered up just few minutes back, right? So in that case also you will be able to get the time complexity as big O of n. So overall, in a nutshell, the scenario is, for every scenario, for every case, the time complexity that we are getting is big O of n only. Perfect. That's completely fine. Now, what's next? So here if you will see, we have talked about preorder traversal. One more thing that is important to understand in the best and the worst case scenario in the recurrence relation is about the stack space that we are using as an extra space here. So when I'm talking about stack space, so when I'm talking about a best case scenario, what is happening is that if you will observe, if suppose we will be having maybe 8 or 9 function calls inside the node, so usually what happened is that the stack space will be equals to log of n base 2, that you can see as well. So here if you will see how many number of levels we are using, that is something which we are calling as a stack space. So we are using 4 space. So here if you will observe, we are having n value as 5, right? So approximately if you will solve this, you will be able to get that, okay, the number of levels will be approximately equals to 4. But when you are dealing with a worst case scenario, means a skew tree, for example, you will be having data like this. 1 is there, 2 is there, 3 is there, 4 is there, 5 is there, something like this. It is something which we call as a left skewed. There if you will observe the stack space, you can try at your home, when you will do the function calling, the stack space is almost equals to the value of n. So that's why here the stack space is something which is equals to big O of n only. Whereas in case of a best case scenario, it will be usually equals to log of n base of 2. That is the another important thing that you need to understand. Now, one last traversal which is pending is the post-order traversal. So here if you will observe, let me talk about the very last traversal of today's session, which is post-order traversal. Again, I am saying things will remain same, only the pattern will get changed. So what will happen here? If you will observe, in case of a post-order traversal, it simply says that if the value of the root is not equals to none, do one thing for me. First of all, so here what I can do is that I can simply do one thing. I can call maybe post order, and inside that I can pass the root node. So if the value of the root is not equals to none, I can do one thing here. What is that thing? I can say I will do post order of, first of all I will traverse towards left completely. Then I will start traversing towards right completely. And at the very end, what I can do, I can simply call again the function post order here, right? Post order of root dot data. So sorry, printing will be there. So at the very last step, we are doing a printing. So if you will observe, in the Inorder, I was doing the printing in between. In preorder, I was doing the printing of the data at the very first part of the node. In the case of a post order, the same printing will happen at the very ending stage. So this is where I would say the printing will happen. So here I will print the value of root.data, right? Again, if I will try to demonstrate you the same thing, so how basically these things will happen? So here again, if suppose I will be having this kind of a tree where 1 is there, 2 is there, 3 is there, 4 is there, and 5 is there. So what will happen? Again, you will start from post order of 1. Now again, you will start first of all traversing towards left. So you will call post order of 2 first. Then you will call maybe post order of, I would say, 3. And after that, you will go towards printing the value of 1, which is the data, actual data that we have. Again, this function will be called, what is the value present at the left side of 2? It is something which is equals to 4. So again, the value of the post order of 4 will be called. In between, if you will observe, the post order of 5 will be called. And finally, we can print the data which is equals to 2 here. Can I say? Can I say? So this is something which is equals to 2 here. So here, if you will observe, again, at this point of time, what will happen? What is the value present at left side of 4? It is something which is equals to none. Can I say? Again, at the right side of 4, it is equals to none. So post order of none will be there. And after that, data will be printed. Correct? So basically, here again, if you will see, post order of none, because at the left side of 5, there is a none value. Again, in between, post order of none will be called. And at the extreme right, the value of 5 will get printed. So here, if you will observe, the value of 4 will be printed first. After that, the value of 5 will get printed. After that, the value of 2 will get printed. And after that, so basically how printing will work, this function will be called, then this function will be called, then this function will be called, then this function will be called, this function will be called, finally 4 will be printed. Then it will again go back, again this function will be called, this function will be called, again 5 will get printed. Now again it will go back, 2 will be printed, right? Again it will go back, at the post order of 3, again same thing will happen. What is the value present at the left side of 3? I think it is none only. What is the value present at the right side of the 3? It will be again none, I would say. And what is the printing? It will be 3 again. So again, if you will observe, this is nothing, none, 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 it will return. 3 will be printed and finally 1 will get printed. So 4, 5, 2, followed by 3, followed by 1, right? This is the overall pattern that we will be able to get. And you can clearly see without creating a, again, recursive tree also. So if you are a beginner, start with the recursive tree. If you already understood the complete overall idea behind that, and if you are pro with the recursion concept, you can do directly as well. Go towards left, 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 4 will be there. Then right, 5 will be there. Node, 2 will be there. Left is completed. Then go towards right, 3 is there. After that, finally, node 1 will be there. So the root node will always be the last. The root node in the tree will always be the last in case of a post order traversal. The root node will always be the first in case of a pre-order traversal. The root node will always be in the middle in case of a in-order traversal with the pattern that we are observing here, right? So the same thing which we are getting. So this is the expected output from our code as well. So important point that I told you here is that one thing that you will observe always, that the root node of a tree, if I will talk about in case of a traversal algorithms, right? If suppose you are dealing with a in-order traversal, in case of that, it will be always in the middle. The root node will always be in the middle. If suppose I am talking about a pre-order traversal, then the root node will always be at the first part. If suppose I am talking about something called as post-order traversal, then the root node will always be the last node. This is how basically the traversal algorithms will work, right? This is the important point to conclude here. Now, without wasting any time, what we can do is that we can do the same implementation for the same thing, post-order traversal. So now what I can do is that I can here itself in the same file try to create another function definition. So here I can create the function definition of post-order traversal, right? So here def, I would say post-order, and inside that I can pass the root node. Now I can say that if the value of the root is none, what I can do here is that I can simply call the post-order for the left side of the root node. After that again, so here this is the, I would say, recursive call for the left subtree. Recursive call for the left subtree. Again, we can make a recursive call for the right subtree. And after that, finally we can print the data. So we can say print str of root dot data. And after that, we can say end is equals to none. So this is something that we will be able to get. Okay, we didn't make a recursive call. One thing that we need to do is that before that we need to make a recursive call towards the right side of the tree. I think now we are good to go. So recursive call for left will be the first, then for the right will be the next, and then finally the printing thing will happen here, right? Now what we can do here is that we can again take one space here, and after that I can say print post-order traversal, right? And after that what I can do here is that I can simply say post-order, and inside that I can pass the root node. If you will observe 45231, I think this is the same thing that we are getting in our PDF as well. Let me try to open that to just get the confirmation. Yes, 45231. This is what we are getting in the implementation part as well, right? So in a way, what we have seen is that we have seen tree traversal algorithms implementation. By saying that, we have talked about all the three standard algorithms. We started with the Inorder traversal, then we talked about preorder, followed by the post-order traversal. After that, we also did a great discussion about the recurrence relation. With the help of that, we will be able to conclude that for every case, whether we are talking about best case, average case, or the worst case, the overall time complexity of the code will be something which is equals to big O of n. Now, what is your task? What is your assignment, or I would say practice task, is that we have implemented everything, whether it's a part of a, I would say, pre-order traversal, or it will be a part of post-order, or it will be a part of in-order. Everything we did in recursive relation, right? Everything we did it in the form of a recursion. So what I'm saying is that the practice task says that do all the traversal algorithms implementation, but now with the help of I would say without recurrence, without or without recursion. That is simple. So you need to do all traversal algorithms implementation. By saying all, it means I am talking about again Inorder, preorder and postorder, without calling the same function again, just like the way we called here, right? And then do let me know who will be able to get the correct output. Yes. So with this, I hope that you will be able to get the clear-cut idea about the all different kinds of tree traversal algorithms that we have inside the tree, right? With this, I would like to end this particular session. If you still have any sort of doubt or you are feeling somewhere trouble, so you can let me know and I'll try to resolve it as soon as possible. With this, happy learning to all. Bye-bye everyone, and I'll see you all in my next upcoming video.